So, guys, we're going to talk about probability and we're going to define some terms. Before we get into probability, we have to know what we mean by natural numbers. Natural numbers are numbers like 1, 2, 3, 4, 5. 0 is not a natural number. And whole numbers are basically natural numbers with 0. So whole numbers are 0, 1, 2, 3, 4, 5, and so on and so forth. What are integers? Integers are 0, plus minus 1, plus minus 2, plus minus 3. It goes on and on. So you have to understand these sets. Natural numbers are 1, 2, 3, 4, 5, 6, goes on and on. Whole numbers 0, 1, 2, 3, 4, 5, 6, goes on and on. Integers 0, plus minus 1, plus minus 2, plus minus 3, goes on and on and on. Okay, let's move to the next topic. We are now going to define a few terms. These are directly related to probability. An experiment. What's an experiment in probability? An experiment in probability is an activity whose results can be observed and recorded. For instance, you can roll a die, that's going to be your experiment. You can toss a coin, that will be your experiment. Each of the possible results of an experiment is an outcome. So if you roll a die, a regular six-sided die, your outcomes can be 1, 2, 3, 4, 5, 6. If you toss a coin, your outcomes can be head or tail. Another important term that we will use a lot, sample space. Sample space is the set of all possible outcomes. For instance, if you're rolling a die, your sample space, regular six-sided die, your sample space is going to be this. This lists all the possible outcomes. If you are tossing a coin, you could possibly get a head or a tail. Your sample space is going to be H and T. Now, we write sample space using set notation, okay? So sample space is a set that contains all the possible outcomes, all right? So these notes that you're seeing, I'm scrolling through, is available on your Go View. Take a look in the notes folder. I am writing things, so I don't have to go over every single slide. Okay, this is a good one. A random event denotes an outcome of an experiment on which no external conditions are imposed. So a random event is something, so when you roll a die, getting a one is a random event. You have no way of controlling what you're going to get. Assuming they're all equally likely, getting a six or a head when you are tossing a coin is a random event. You have no control over it. Okay, here's a good one. We need to kind of talk about it a little more carefully. So, so uniform sample space. So let's say I have a bag containing two blue marbles, two green marbles, and two red marbles. Uniform sample space means the probability that the likelihood that you will get a blue marble is same as the likelihood that you will get a green marble, which is same as the likelihood that you will get a red marble. So they're all equally likely. All the outcomes are equally likely. Now, if all the outcomes are equally likely, we call the sample space a uniform sample space. When you roll a die, the likelihood of getting 1, 2, 3, 4, 5, 6, each is 1/6, and the sample space is uniform. When you toss a coin, the sample space is H. Sample space contains two outcomes, H and T. Both are equally likely, one half and one half. And we're going to define probability in a second. That would also be a uniform sample space. Of course, if we talk about uniform sample space, we must also talk about non-uniform sample space. A non-uniform sample space is where things are a little off kilter. So something is more likely. Clearly, you can see there are four blue marbles, one red marble, one purple marble. The likelihood of getting a blue marble is much more. So you're more likely to get a blue marble than a purple marble or a red marble. So I would say this is a non-uniform sample space. These are just terms that we will use when we solve problems in this chapter, in the probability section. So what's an event? Event is a collection of outcomes. However, an event could have no outcome. So when you're rolling a die, the set of even numbers getting 2, 4, 6 is called an event. The set of odd numbers getting 1, 3, or 5 is called an event. You can also describe an event like getting a number larger than 3, 4, 5, 6, getting a number less than or equal to 3. So that would be 1, 2, or 3. So all these are events. Events are a collection of outcomes. Now, the event could be your entire sample space. The event could have nothing in it, could be an empty set too. Be aware of that. All right, now we're going to define probability formally. So instead of defining this formally, an experiment with a sample space of S and with equally likely outcomes, the probability of an event A is given by P of A. It's simple. I'm going to give you an example, okay? So let's say you have, you are rolling a die, six-sided fair die. Your sample space 2, 3, 5 it is 4, 5, and 6, and they're all equally likely, right? Now, your probability will be this. What's the probability of getting a 6? We write it like this. Probability of getting a 6 in this case is 1. There's 1 6 out of 6 outcomes. What's the probability of getting an even number? I'm going to write it like this. Probability of getting an even number when you roll a die. And that's going to be there are three even numbers, 2, 4, and 6 out of 6. Probability is kind of like fractions. Okay, so now we kind of know how to find basic probabilities formally. Here's the formal definition. Here is how you do it. And you have more examples in your notes. Take a look. I've given you a couple tons of examples here. Okay, let's work on this a little bit. So when you have a deck of standard deck of cards, standard deck of cards, and just to let you know, you will exams will be open book. So you want to have a copy of this, which is in your notes. So in a standard deck of 52 cards, each deck has four suits. These are the hearts, these are the diamonds, these are the clubs, these are the spades. The clubs and spades are black, and the diamonds and hearts are red. And the cards are numbered 2, 3, 4, 5, 6, 7, 8, 9, 10. Then Jack, Queen, King, and Ace. Jack, Queen, and King are also called face cards. And you have to kind of remember that. Face cards, because they have a face on that on one side of the card. And Ace is not a face card. And the rest of the cards are numbered 2 through 10. Each suit has 13 cards. Okay, if you count 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And there are four suits. 4 times 13 is 52. The deck has 52 cards. Each suit has 13 cards. The red suits are hearts and diamonds. The black suits are clubs and spades. Not too bad. Let's do some problems. So here, I'm gonna not even gonna take it to the next page. You can see here, you have a standard deck of cards. What's the probability of drawing a red card? Well, there are 26 red cards out of 52. So your answer is 26 over 52 or half. What's the probability of drawing a 10? In a standard deck of cards, there are 4 10s. So you take 4 divided by 52, which is also 1 over 13. What's the probability of getting a card that has a letter on it? There are 16 cards with letters, Jack, Queen, King, and A times 4. 16 divided by 52 is 4 over 13. That's the probability of getting a card with a letter on it. What's the probability of getting a face card? Remember, I said Jack, Queen, and King are called face cards. They're all together 3 times 4, 12 face cards. So the probability of getting a face card is 12 over 52. Now, when we say or, guys, you have to kind of understand it's either this or this. Sometime it'll be both. So what's the probability of getting a 2 or a 4? Well, there are 4 2s and 4 4s. So altogether, your favorable outcome, the outcome that you're using to find the probability, they're called favorable outcomes, is going to be 8. There are 4 2s, 4 4s. 4 plus 4 is 8. 8 plus 8 divided by 52 is 2 over 13. All right, I think we're making some progress. Okay, a couple of basic things about probability that you need to know. That the probabilities will always be between 0 and 1. The probability of an event is 0 if it never happens. The probability of an event is 1 if it will always happen. So, for instance, if you're rolling a die, what's the probability of getting a 7? 0. Okay. What's the probability of getting a number that's between 1 and 6, including 1 and 6? That's 1. When you roll a die, you will always get one of those 6 numbers. So this is called a certain event probability. When the probability is 1, the event is certain. When the probability is 0, we call it an impossible event. It will never happen. Here we see some set notation, and I'm going to spend a little bit of time because this word will come up over and over again. So let's go take it here and do it nicely. So events A and B are mutually exclusive if they have no elements in common. So I'm going to go back to give you a simple case. So let's say you're rolling a die and you want to know what's the probability of getting a number less than 3. Your sample space is going to be 1 and 2. And this event is called, I'm going to call it event less than 3. Less than 3. Less than 3 means strictly less than 3. Okay? It cannot be equal to 3. And I have another event, and I'm going to call it greater than 3. And that's going to be 4, 5, or 6. Now, take a look at these two events. This event and this event have nothing in common. Their intersection, where the overlap is empty. Okay? If there are two events that don't have anything in common, we call them mutually exclusive. So if you know that the outcome is 1 or 2, you automatically know the outcome cannot be 4, 5, or 6. If you know the outcome is 4, 5, or 6, you know it cannot be the other one, which is less than 3. For instance, I'm going to call this less than 3 event A, and greater than 3 event B. Okay? A and B are mutually exclusive. That means A and B have nothing in common. If A happens, then you know B didn't happen. If B happens, then you know A didn't happen. That's what we mean by mutually exclusive. Okay, another important term. So they're kind of connected. The next one, complementary events. Okay, complementary events are like this, and you really want to get it. Okay, what's the probability of getting a number greater than 4? Probability of when you're rolling a die greater than 4. And that means greater than 4, you can get 5 or 6, right? Now, what is the complement? Remember when we did sets, complement of greater than 3 would be either 4 or less than 4. Okay? So equal to or less than 4. Equal to 4, I'm just going to write it like this. Equal to or less than 4. And what would you get? Equal to or less than 4? Well, that could be 1, 2, 3, 4. Now take a look at these two events. They're complementary events. So they together form the sample space. Take a look, 1, 2, 3, 4, 5, 6. That's the entire sample space. And they're mutually exclusive. Two events that are mutually exclusive, and when you put them together, you get the sample space. Those two events are called complementary. And there's a very nice relationship. If A and B are complementary, let's call this A, the first event, and let's call the second event B. Sorry. Call the second event B. Now, A and B are complementary. We described it. Now, the probability of A is 1 minus the probability of B, and vice versa. So what's the probability of A? Probability of A is 2 out of 6. What's the probability of B? Probability of B is 4 out of 6. And clearly, probability of B is 1 minus 2 over 6, and probability of A is 1 minus 4 over 6. Or in other words, if you add them, if you add the probabilities of two complementary events, you will always get 1, and that's exactly what we see here. So here is an example of complementary events. Let me take it to the other page. Another example. I gave you one. Let's do one more. These are complementary events. The probability of getting a red marble is 1/3. Probability of not getting a red marble is 2/3. And if you add 1/3 and 2/3, you're going to get 1. These events are complementary. Clearly, they are just mutually exclusive. Getting a red marble means you didn't get a non-red marble, and so on and so forth. And the two probabilities add up to 1. Okay, so we're going to do, it's not a bad place to stop. We'll start with the next one, um, next example in the next video. We'll talk a little bit about fundamental counting principle, which you guys will be teaching in middle school. So that's coming up. Okay, I'm gonna stop recording this video here, but you can see what's going on, what's going to be next.